Previous class we were discussing on vibrationals vibration modes can be perpendiculars or vibrationals. So whenever you look about of linear molecules, any linear diatomic molecules means diatomic molecules are always linear. So diatomic molecules, what you see that here in this type of molecules, diatomic molecules. So here that vibrational modes are always perpendicular, always parallel vibrations. Let's say here the vibrational modes are always parallel vibrations. Will not get any perpendicular vibrations. No perpendicular vibrations. So we can look also, like if I say any molecules, diatomic molecule, let's say HCl. So here if you do stretching or bending, symmetric stretching or symmetric bending. So if I rotate, let's say I'm applying that symmetric stretching. Then what I do, I will do this directions and to this directions. Then again I will get here that principal axis is, let's say, C infinity. Here also principal axis is C infinity. And if I do that at asymmetric stretching, let's say it's here, if I stretch this one and this one this directions, then also you see that this one, so again that C infinity is there. So either you do symmetric stretching or you do asymmetric stretching, C infinity is there. So these are parallel vibrations. Or if I do bending also, let's say HCl, now I will do, this is C infinity. Now if I do that symmetric bending, so if I bend it, let's say here, symmetric bending, and also I will bend it here. Then what you will see that this is the two atoms. So however you will bend, you will get that, let's say if I move this molecules here, H, then Cl also comes, whatever, suppose here, but Cl is here, then also that C infinity is there. And at the same time, if I do that asymmetric bending, let's say here also principal axis is C infinity. Now I am doing that asymmetric bending. So if I bend this one here and bend this one here, let's say H, see again C infinity is there. So for diatomic molecules, whether you bend symmetric, asymmetric, if you stretch symmetric, asymmetric stretching, always you will get, we get parallel vibrations. So in diatomic molecules, the vibration modes are always parallel vibrations. No perpendicular vibrations we get. And but for polyatomic molecules, we can classify two. One is, I can say, linear polyatomic molecules. Another, I can say, non-linear polyatomic molecules. So previous class we have discussed that linear polyatomic molecules, like we can say CO2 types, and for non-linear polyatomic molecules, like we can say H2O and all that, NH3, all types of non-linear polyatomic molecules. For linear polyatomic molecules, we see that we can get either parallel vibrations, also we get perpendicular vibrations. Both are possible. we have discussed in the previous class that CO2, for this either we get parallel vibrations or we get perpendicular vibrations. Let's say here CO2, here we say that sometimes you are getting parallel vibrations, and if I do the bending of CO2, here we are getting that perpendicular vibrations. So this CO2, sometimes you are getting perpendiculars, and sometimes you see that same CO2 we are getting the parallel vibration, this CO2. So it means that for CO2 linear polyatomic molecules, we get the possibility both parallel vibrations and perpendicular vibrations. And what we discussed that whenever we are discussing about of this diatomic molecules, here what we see that here from here we understand that here only we get the parallel vibrations, and also we see that here what we see only P and R branch only we get here. So diatomic molecules, you discussed that there was no Q branch, only P and R branch is present. So wherever that parallel vibrations means only P and R branch. Okay. So now we can say here that the linear polyatomic molecules like CO2, if I say parallel vibrations, here what we get P and R branch we will get, and perpendicular vibration means here we get P, Q and R branch. So here for parallel vibrations, it is similar to diatomic molecules. Diatomic molecules where we get only P and R branch. We discussed that now, like here. So here that we say that this is J equal to 0, J equal to 1, J equal to 2, and this is J equal to 0, J equal to 1, J equal to 2, and this is J dash, double dash, this is J dash, and this is B equal to 1, this is B equal to 0. We say that R branches are like from G0 to G1, G1 to G2. These are the R branch where delta J equal to plus 1s, and R branches are so and this is the R branch, and P branches are from this J1 to J0, and this also this can be this to this where delta J equal to minus 1. So these are the P branch, and these are the R branch, and there was no Q branch, that is J equal 0 to J equal 0. This branch was not possible for linear polyatomic molecules. So here only P and the linear diatomic molecules or diatomic molecules, only P and R branch will get. So whenever you discuss about the perpendicular vibrations, here P branch also possible, Q branch also possible, and R branch also possible. Means here that the atomic levels will be like this. So if let's say some are here to here, so these are the R branch, and let's say some are P branch. Let's say these are the P branch. Okay, and this is J equal to 0, J equal to 1, J equal to 2, this is J equal to 0, J equal to 1, J equal to 2, and this is J dash, and this is J double dash, and this is B equal to 0, this is equal to B equal to 1. So here this is the P branch and this is the R branch. With that, here Q branch also possible, that is from this to this, from this to this, and from this to this. So Q branch also possible. Okay, so why this Q branch is possible for perpendicular vibrations and PQR branch? So that we'll discuss after. Let's sum up all this. After that we will discuss why Q branch is possible. Okay, so for parallel vibrations, PR and P and R branch, and for perpendicular vibrations, both P, R and Q branches are possible. This is about of that linear polyatomic molecules. And whenever you discuss about of that non-linear polyatomic molecules, here both parallel and perpendicular both are possible, and here always we get PQR branch. PQR branch, because for linear polyatomic molecules we know that both parallel and perpendicular vibrations are there. So here we get always PQR branch. And for linear polyatomic molecules, if they have the parallel vibrations, so here also we get PQR branch and PR branch and PQR branch. PR branch due to parallel vibrations and PQR due to perpendicular vibrations. So if the questions ask that in any questions, it says if it is has only PR branch, P and R branch are present, then that is always linear diatomic molecules. Okay. Now the question is why Q branch is possible here. Let's say we discuss that delta E equal to, we say that B, we say that omega naught plus B, and we say that this is J dash minus J double dash, and we say that J dash plus J double dash plus 1. We discuss that delta E is equal to this, and we say that for R branch we consider that J dash minus J double dash equal to plus 1. So if this is plus 1, then we take this one and we take that delta E equal to omega naught plus B, and that we get here after doing that this one we get what, that is we get 2B. That equations, how we get that equations, that is we say that delta E, whenever you do we put the J dash minus J double dash equal to 1, then this is 1, and after that what we say that if I put the J double dash, then J dash equal to J double dash plus 1. So if I put all these equations, what I get, that omega plus B, and this is 1, and this is J dash is J double dash plus 1, and we have J double dash plus 1. So whenever you do it, then what will you get, omega naught, omega bar, and this is B, and this is 2J, and that is 2 double dash plus 2. So whenever I calculate it, then what I get, that we already did it, that is 2 commons, and sorry, omega naught plus 2B J dash plus 1. So this one we take whenever we considering that R branch, and whenever we considering for P branch, what we say that these equations, if we put it here, then what we get, that delta E is here, what we say that J dash minus J double dash equal to minus 1. So whenever I put this equation, this is equation 1. So whenever I put this in equations 1, what I get, that delta E is equal to omega naught, omega minus 2B and J dash plus 1. So this is for P branch, that we already did it. So what I say that this is our the main equations. This is our main equations. So what I say that for P branch and R branch, whenever you're taking that, we're taking these equations. And for R branch, if that J dash or J minus dash, for this value to get 0, let's say this whole value to get 0, we need that J dash equal to minus 1, or here J double dash equal to minus 1. Then only we get that delta E equal to omega. But this J double dash equal to minus 1 is not possible, because what we say that our this is started from J equal to 0, J equal to 1. Okay, that's why here this delta E is equal to omega is not possible. But whenever we are discussing about of that polyatomic molecules, what we do here is we put these equations, and for perpendicular vibrations, But we say that delta E equal to omega naught plus B Z dash minus Z double dash and Z dash plus Z double dash plus 1. So whenever perpendicular vibrations we are discussing, then what you say that here we can put that Z dash. So for getting omega naughts, we can do that this value as 0. So to get omega naughts, we can put this value as 0, then we get only omega. So to get this value 0, what I do, delta E equal to omega plus B, and if I do that, Z dash minus Z double dash equal to 0. That is how it is possible. Z dash equal to minus Z double dash equal to 0. That is possible if Z dash equal to 1 and Z double dash is equal to 1. Then we can say Z dash minus Z double dash equal to 0, because this is 1 minus 1 equal to 0. So for that, if we put this value as 0, then we get that whole value is 0. If say this is 0, then this is also 0. So 0 and 0 of 0, that is omega. That is delta equal to omega. So what I say that for perpendicular vibrations, we take that this value is 0. So to get this value 0, we can do what? Let's say, so if this is J equal to 0, this is J equal to 1, this is J equal to 2, this is J equal to 0, this is J equal to 1, this is J equal to 2, and this is for B equal to 1, this is B equal to 0, and this is J double dash, and this is J dash. Then if I do the transitions, that I need the J dash minus J double dash equal to 0. So for that, if I do the transitions from 0 to 0, then I say that 0 minus 0 equal to 0. Or if I do the transitions from 1 to 1, then I can say that 1 minus 1 equal to 0. Or if I do the transitions from 2 to 2, 2 minus 2 equal to 0. So this is possible for perpendicular vibrations. If you put these equations over here, okay, if I put that Z dash minus Z double dash equal to 0, then I get that whole value 0, and this delta E equal to omega naught, I can get it here. But for whenever we are discussing specifically for P branch and R branch, we are putting that Z dash in these equations. We already derived these equations from here. So in this P branch and R branch, we are putting that Z dash minus Z double dash in these equations. So in these equations, we not get that this type of transitions. Okay. So this is called the Q branch. Q branch. So here what we say that here delta J equal to 0. So now so for PQR branch, what you get here, let's say if I do here this type branch and sorry, let's say this is, or I can, let's say this is J equal to 0, let's say this is J equal to 1, let's say this is J equal to 2, Let's say this is j equal to 0, let's say this is j equal to 1, let's say this is j equal to 2. I'm not taking this. So if this is let's say this is b equal to 1 and let's say this is b equal to 0, so now this is j double dash and this is j dash. So if I do that for PQR branch, what that the transitions are there. So for R branch, what that j equal to 0 to j equal to 0 to j equal to 1, this type of, and j equal to 1 to where delta j equal to plus 1. And for Q branch, what is that j equal to 0 to j equal to 0. These are the Q branch. And for R branch, sorry, P branch, what is it? This is R branch. This is Q branch. And for, if I talk about a P branch, then what it is here to here. This here, this is the P branch. Here delta j equal to -1, here delta j equal to 0, here delta j equal to +1. So this type of transitions, and whenever if you draw that spectroscopic the spectrums, then how it look like. So this is, here we will get that omega knots, and here we will get R branch. So here we get that R, this is omega knots. So dark peak we will get here, and here we will get R branch, and here we will get the P branch. Here we get the P branch, and here the value is delta j equal to +1, here delta j equal to -1, and it starts from P1, P2, P3, P4 and P5, and it starts from R0, R1, R2 and R3 and R4. Why it starts from R0, why it starts from P1, that we already discussed, because the transitions are from this one is erased. The transitions are from j equal to 0, that's why for R branch, that's why this is starts from R0, whereas for E branch it starts from j equal to 1, this, so that's why this is starts from RP1. Okay, and we have discussed that each distance, that is 2b, 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 here also this is 2b, 2b, here also it is 2b, 2b. Okay, and we discussed that here this is again 2b, and this is also again this is 2b. And what you see that here that Q branch, that peak will come, this dark peak will come, dark peak. The regions, because of this dark, the regions of getting dark peak is that whenever you do that transitions from j equal to 0 to j equal to 0 for Q branch, I'm talking about a Q branch. So here whenever you do transitions, whether it may be j equal to 0, j equal to 1, all that clear case, what we are getting that only omega knots. So let's say I will do the equations. So if I search delta E equal to that is omega naught omega plus b j dash minus j double dash, and this is j dash plus s plus 1. So now if I take about of j, so j dash equal to, if I'm taking 1, and z dash also I am taking 1, then what I will get, this value will become 0. So here we get delta E equal to omega plus this value is 0. So if this value becomes 1 minus 1, that is equal to 0. So if this value is 0, then whole value will be 0, then all things will be 0. That is omega naught. Similarly, if I do delta E omega plus B, here if I take 2 because here I am taking j dash equal to 0 and j dash equal to sorry, this is 2. Here also I am taking, then also I am getting 2 minus 2 and this all value, and then again it is getting 0. So again I am getting this equal to omega only. So whatever the transitions I will do, all the case it falls only in the omega. It means that whatever the transition, whether you are doing from j equal to 0, j equal to 1, j equal to 2, j equal to 3, whatever the transitions you are doing, always the peak is for falling at omega. So this intense will become a dark intense. Okay. So we have discussed that linear molecules, for diatomic molecules always P and R branch always. And for linear polyatomic molecules, both parallel vibrations and perpendicular vibrations. If getting parallel vibrations, then PR and R branch. So PR R branch means always these are parallel vibrations. So for linear polyatomic molecules, we can get both parallel vibrations and perpendicular vibrations. And for linear polyatomic molecules, we get always PQR branch. So these are about of this R branch and linear molecules and non-linear molecules. And for non-linear molecules, we say that they have both parallel and perpendicular vibrations. So whenever we are discussing about of non-linear molecules, we get always PQR branch. And for if we say for linear polyatomic molecules, then if we have the parallel vibrations, then we will get PR branch. And if it has the perpendicular vibration, then we will get PQR branch. And for linear diatomic molecules, always P and R branch. So today up to this, thank you.